I'm Anil Kumar. Let me thank all the viewers and subscribers for watching my videos and posting great suggestions. I get many questions every day. These are the two questions which I have picked up. The idea is to show the solution in different ways. And then it's up to you which method you can adopt to solve them, right? Question number 1 is, find two real numbers that have sum of minus 10 and product of minus 5. Question number 2 is, A 5 5, B minus 7 1 and C 1 minus 7 are vertices of triangle ABC. Show that the triangle ABC is an isosceles triangle. Very different topics, right? So one we are talking about quadratic equations. The other one is coordinate geometry. Correct? Let's see how to tackle such questions. The first one. Two real numbers means let x and y be real numbers. Right, that's how we'll go about. Sum is minus 10. That means x plus y equals to minus 10. Product is minus 5. That means x times y is minus 5. Now these equations relate x and y. We could isolate one of them. So let's say y is equals to minus x minus 10. So we are going to substitute this value here, right? So we'll substitute this value of y in this equation. So what do we get? We get x times minus x minus 10 equals to minus 5 minus x squared minus 10x equals to minus 5. Take it to the right. So we get 0 equals to x squared plus 10x minus 5. We get our equation. Perfect. Now that is definitely a good way of solving this equation. A standard method. You cannot go wrong with this. Correct? The other method here is that we have learned about sum and product. Correct? You remember sum and product? We always do factoring, right? If you have to factor a quadratic equation, you use sum and product. Perfect. Now this sum and product method can actually be very effectively utilized to solve such questions. The idea is the equation is basically x squared minus sum of roots times x plus product of roots equals to 0. Is that true or not? Perfect. But there are very few students who normally use this method, and that makes a huge difference. See how? What are we given? We are given sum as minus 10. So I could write my equation as x squared minus sum is minus 10, right? X plus product is minus 5 equals to 0. What do you notice? Just in one step, we actually got our equation. Perfect. So that is what I say, alternate methods. You might be working on this chapter. You have already learned that part. When you started, before quadratic equation, you did factoring, correct? So you learned this. And if you apply it, how easy it becomes, right? Now, we actually get easy solution. We can write this as the equation which was expected, of course. Solution is what? X equals to, well, let's write down the quadratic formula also. So the value of x will be minus b plus minus square root of b square minus 4ac over 2 times a, right? For any general quadratic equations which we are saying ax square plus bx plus c equals to 0, correct? So let's substitute the values. We get minus 10 plus minus 10 square is 100 minus 4 times minus 5. Okay. Divided by 2 minus 10 plus minus square root of 120 divided by 2, or well, that could be written as 4 times 30, right? So let me just write minus 10 plus minus 2 square root 30 over 2. So we get the value of x as dividing by 2 minus 5 plus minus 2 cancel square root 30. So these are the two numbers. So we get our answer as the real numbers are minus 5 plus square root 30 and minus 5 minus square root 30. Clear? You can always test it out. So when you add them, you get twice minus 5, which is minus 10, and the product will be, since this is negative, we get a negative product, a square minus b square, so you get minus 5. Is that clear? So those of you who actually adopted this method would have done this question in much lesser time, and that is kind of important. Now let's look into question number 2 also. Now this question I received actually a couple of days back, but there is a suggestion that you can find the distances, right? Yes, we can of course find the distances, and let us see how to solve this in different ways, right? So let me just show you this point on a graph. We always draw a rough sketch. That is the best thing to do. 5, 5 somewhere here, right? Minus 7 and 1 somewhere there, and 1 and minus 7 somewhere there, right? So we'll just connect these points to form a triangle, just to give it a visual look, right? Okay. So the points here are A, which is 5, 5. B, which is B is here, minus 7, 1, which is B, and C, which is 1 minus 7. Now, the question clearly writes, we are looking for isosceles triangle. So definitely, you have to find the distance between points, which is this formula, right? x1 minus x2 whole square plus y1 minus y2 whole square root. That's the formula. We can surely do this, right? So let's find the distance between A to B. So the distance between A to B, always positive. A to B will be square root of 7 minus 12. We can do 5 minus 7, which becomes plus 7, which is 12. And then we'll do 5 minus 1 whole square. Good. So that gives you, this is 12 square, which is, let me write 12 square plus 4 square. Okay, so which is square root of 144 plus 60. Okay, let me just keep it here. We don't really have to find the distance, right? Now, what is B to C? So B to C will be 1 minus 7, which will become plus 7, plus minus 7 minus this, so minus 7 minus 1 whole square. So both are 8, right? So we get 8 square plus 8 square, which is 64 plus 64 square root. Now let's see what is A to C. So A to C is square root of, let's do 5 minus 1 whole square plus 5 minus 7 makes it plus, which is 4 square plus 12 square, right? Which is 16 plus 144. So clearly we are looking for isosceles triangles. We find these two matching values. So we can write that AB is equals to AC, therefore isosceles triangle. You can of course calculate the values, not very difficult, right? These are easy values to work with. But the idea here is to actually share with you alternate method, which is, you love it. So let's talk about alternate method. Now, that is a key. So we actually could solve this using vectors, which is known to many students, right? Since I have a wide variety of students here who are even taking and preparing for IIT JEE, so they could use vectors, or even any high school student for that matter. So it's a common topic in grade 11 and 12 these days. Okay. So using vectors, we can find what is AB, right? So what is A to B? Think like this. A to B, we want magnitude, right? So we write like this. A to B is how much? Let's use a different ink. So we say A to B, we say A to B is what? So B minus A coordinates. So it is minus 7, minus 5. Do you see? This minus that, just as you do, right, normally. So this is your X change, and the Y change is 1 minus 5. 1 minus 5, right? So that is what you get as AB, right? Which is basically minus 12 minus 4. All right, so that is a position, right? It is like this. So for those who new to vectors, right, let me just give you one. If I have a point xy, which we have now, the distance is how much? How much is this distance? R. Well, that will be, R will be x square plus y square square root, correct? That's how you find the distance. That is your distance formula basically, right? And that is what it did here. Do you see that? You got exactly similar values, correct? So if you match, they're same. So that is the distance, right? So basically the distance is same as we wrote here, but not much mathematics involved. I mean, working with numbers is simpler, right? Now let's see what A to C is. You could do B to C also. And A to C is how much? So if I do A to C, right, from A we are going to this, from A we are going to C, then the X change is how much? 1 minus 5. And the Y change is minus 7 minus 5. Is that true? So which is basically minus 4 minus 12. Do you see those things? So for both, if I find the distance, which I write like this, absolute value of this will be a square plus b square square root will be minus 12 square plus minus 4 square square root. You see, you get the same value, right? Which is same as A to C, which is also equal to minus 4 square plus minus 12 square square root. So we get the same distance. But the idea is, as soon as you get these two values same, you know, well, they are same, so they will give you the same distance. Since squaring will make both of them positive, right? So you get exactly the same distance. So immediately, once you have set of points, you can find a distance using this strategy of vectors, which is very helpful, and get your solution. And you can say, well, AB equals to AC, because that is how it is. So I hope you understand and appreciate this strategy of vectors. Extremely important and can be applied in so many different ways, even for finding a new coordinate point, right? So if the question has been changed, let me change this question. So question number 3 for you is find, let's say we are not given C, right? We are given A and B. Find coordinates of C so that AB equals to AC. Now let's say I change the question. I say, well, you are given points A and B, you need to find C, okay? But I'm saying that that will make an isosceles triangle. You get my idea? The other way. Now if I give you this question, then imagine how easy it will be working the way I told you just now. Right? Try it. Try this question now. Let this be your question and share your solutions. I hope you learned and enjoyed from there. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.